Okay, so as I've told you, I'll be solving the dynamic programming problem playlist that has been created on Leetcode, and that problem list is actually very accurate, because if you are going through any problem in the on DP, so that problem might be related to that list that have to have there. Okay, it's because they have covered all sort of types of dynamic programming. So now I'll be solving the second question of that list. It's Fibonacci number. It's actually a easy problem, but there's a lot of to learn. Okay, and these easy problems are actually the good way to start with dynamic programming, because here you can visualize how dynamic programming are working. Because in two-dimensional dynamic programming, three-dimensional dynamic programming, you will not be having visual representation. So here you can have visual representation. Okay, so this question is saying the Fibonacci number, commonly denoted ff1, form the sequence called Fibonacci sequence such that each number is the sum of two preceding ones starting from 0 and 1. So basically they are saying, if we have to find out the nth Fibonacci number, so in that case what you are required to do is, if you have to find n equal to 4, then for like for fourth Fibonacci number, you should have knowledge of third Fibonacci number and second Fibonacci number, because nth Fibonacci number will be calculated by third Fibonacci number plus sum of second Fibonacci number. So this is the actual way to solve it. So if you have to find nth Fibonacci number, then you have to add two Fibonacci number sequences, that is n minus 1 plus n minus 2. Okay, so and one more thing, you can't do it like it is actually in bracket. You can't break this bracket. Okay, it's actually a function, so you can't do it 2n minus 3. It's not like that. It's actually a function. It is f of n equal to, it's actually this actual representation is this, f of n is equal to f of n minus 1 and plus f of n minus 2. Okay, okay, so it is actually formula, it's not actually this thing. Okay, so this is actually formula, this will be using. So you can see, for finding nth Fibonacci number, you have to find out n minus 1th Fibonacci number plus n minus 2th Fibonacci number. So it is actually a recursive formula that you have to follow in a loop again and again and again. Okay, so so you can see here, if you have n, so we will do this: return fib of n minus 1 plus fib of n minus 2. So you can do this, because I have told you it's function of n minus 1 and n minus 2, but the one catch is here, because that catch is the base case. So suppose you set n equal to 3, suppose you are saying n equal to, not 3 equal to, n equal to 2. Okay, n equal to 2. So in that case you will first calculate first Fibonacci number, then you will calculate 0th Fibonacci number. Okay, so again you will calculate 0th Fibonacci number for this, and minus 1th Fibonacci number. But actually the case is, there is no such minus 1th Fibonacci number. It actually starts from 0. So you have to add one base case where this recursive call should be stopping. Okay, so if you got something like this, like if either n is less than or equal to 0, so until it is, sorry, either n is, yeah, okay, is less than or equal to 0. So if n is less than or equal to 0, in that case return 0, because there might be case you are finding minus 1th Fibonacci number. So in that case there is no such thing, you have to return with 0. Okay, and if n equal to 2, sorry, 1, and the first Fibonacci number is, I have told you, is 1. Okay, is 1. 0th Fibonacci number is 0 and first Fibonacci number is 1, and second Fibonacci number is also 1. So if you run this code, you will see you can get all the answers that is in test case. Okay, okay, you can see all the test cases are respected. But the problem with this code is, it is actually very extensive. This code has lot of calculation over there, because every time you will calculate n minus 1, then n minus 2 for every n, and you can see there is lot of redundancy. If I have to show you with that, then you can see in this family tree, actually for n equal to 9, you have to calculate the 8th term, 7th term, you have to calculate, then again 7th term, then for 7th term you have to calculate 6th term, for 6th term you have to calculate 5th term, then for 5th term you have to calculate 4th term, and all and all and all. So if you see, you are calculating for n equal to n, you are calculating 8th term, for 8th term you are calculating 7th term. So why are we doing this twice? You can see you are doing this here, and we are also doing this here. So why are we doing this? Why are we going to calculate all these things? Because afterwards you can see this is same tree. this tree and this tree, you can see this is the same tree. So if you calculate answer for this, suppose this answer for this is x, okay, answer for this is x, you can pass this x here, you will pass this x here, okay, and answer for this is y. So for this you will return answer equal to x plus y, okay, x plus y. This actually works, okay. So and is this family tree is exactly same as this family tree, okay. So why are you calculate there? We don't need to calculate it, okay. So if somehow we store the values of our priorly calculated thing, then we need not to store these values. So what, for that say common chance, we can do memoization. So if I have to show you this, suppose I'm taking a map, okay, or I said say map, okay, map of unordered map. I'm taking unordered map int supposed to, okay, it's m, okay. So suppose initially there is nothing, so suppose we have calculated for suppose we have started with n, and now for n equal to 7 we have to calculate for this 7. Suppose we are going through this 7, but priorly we have calculated value for this, so we will check, do this whether we have priorly calculated value or not. So whether if we have calculated priorly, sorry about that, priorly, if we calculate priorly, then we will not do it, okay. Then what we will do is, if m dot count means if you have already found that value for n, if it is there, if it is there, m dot count is there, then in that case we will return m of n, okay. We will do this, and when we are returning the answer, in that case we will also store the value of whatever we calculated, because we have to store it. No, I've told you here, if we store this value, this x value, so we are storing the value of x. This is we are doing by this, and if now we will run this, then you can see it will also be working. And I am not sure we are using map it will be working or not, because map have different complexities. If we array, they have different complexities, but let's submit it, okay. Okay, so it's actually submitted. You can see here it's accepted, okay. Instead of map you can use some array as well. I am using map because I don't know how long array I should use, because we have to calculate up to n, so I don't know how long we have to use that array. Suppose 10 values, what we can do is actually we can go through this constant is 30, so max to max array will be 30, so I can use that, but I am using map because I am not wasting any bit of the memory, okay. So this was the second approach, but this was a memoization approach. There is one more way to solve this problem, that is actually a recursive, it was a recursive way, this is actually iterative way. So I am going to erase everything, okay. Yeah, these two actually are important. So now I am going to erase everything, implementing iterative, okay. So in that case what we will do is, you can see we have to always keep track for n equal, for any given n we should have value of n equal, we should have Fibonacci numbers, Fibonacci terms n minus 1 and n minus 2. So if you see, there is two dependencies for any given n, if we know two prior values, if for n term, if you know n minus 1 term, okay, and n minus 2 term, okay. So in that case we can easily find this n, okay, this term you can easily find by adding these two terms. So if we have, if we take two variables, suppose saying first and second, int first and comma second, okay. So easily what will be these first two, because we have to start with n equal to 2, because nth Fibonacci for n equal to 0 and n equal to 1 we have that. So we have to take those things. Suppose first will be here, suppose from 2 will for n equal to 2 we will be starting. So first here will be, first will be 0 and second will be 1. So this is actually 0 term and first term, okay. So if we have to find out nth, so what we will do, if while okay, suppose we are using for loop for int I equal to 2 and I is less than or equal to n, okay, and I plus plus, okay. So we will say one thing is here, answer int answer equal to 0 instantly. Okay, so we'll say answer equal to first plus second. Okay, last two terms we are using, and we have to update last terms. Okay, so now first will be setting second because it will move one step ahead. First will be second, and second will be this answer. Second will be answer. Okay, and then if you return our answer, then you can check it actually. Okay, let's see if it is working or not. There might be a compilation error, maybe. Okay, actually it is working. Okay, so now we can test on some test cases. Suppose we can test on n equal to, suppose 5 we are testing, not 5, we are testing 10. Okay, it will be actually hectic because for 10, 2 to the power 10, something like that we will be using as a complexity. So it is actually working. So this was a whole code I have showed you. Even we can use array for this. We can't use this. We are using 3 variables. We need not to use those 3 variables. We can take an array and we can do this thing like we can take an array like this. Suppose n equal to 5 we are using, so we can take an array 1 2 3 4 5 and 6. Okay, suppose we are using this. So suppose n equal to 6 and they are asking about their 6 like 6th Fibonacci term. So we know the 0th term is 0 and first term is first, so we can iterate over this array, and second term we will calculate by this. So you can add these two, this will be 1. Third term we can add these two, so this will be 2. Fourth term this will add these two. For fourth term this will be 3. For fifth term we can add these two, this will be 5. And for sixth term we will add these two, it will be 8. So you can see for n equal to 6, for n equal to 6 you will see the answer will be 8. Okay, let's check whether it is working or not. It should work actually. Okay, so if we do this, first case we are removing, suppose we are saying 6. Okay, let's run it. So if you run it, it should be coming out as 8. Okay, it is coming as it. Okay, you can see. So this was also possible. I didn't went to this because there we have to use this. This is actually dynamic programming problem, how we solve actually. Okay, but it is manageable by only 2 variables, so I'm doing that. Okay, so there is one more interesting thing that you will never go through this thing. Okay, it's actually a pure mathematics thing. If you are going through some dynamic programming, going through some extensive CP problem, and suppose you have to find out like nth n like n terms of Fibonacci number. So suppose same like this, what this code is taking, suppose this code is taking order of n. Okay, suppose your n is equal to 100, so complexity of this code will be order of 100. Okay, order of 100 the complexity will be. Okay, so this is order of n solution. But what I'm going to tell you about order of 1 solution, it is actually very important in CP competitive program, because if you know how to calculate a problem, how to calculate you can say nth Fibonacci number in order of 1, it will give you a boost, because there might be some problems where you suppose in one you have to calculate 100 nth terms, like suppose on single iteration you have to calculate 8th Fibonacci number, 10th Fibonacci number, 20th Fibonacci number in same iteration. Then you will be doing in same iteration, you will be calculating again and again. Suppose n times you have to calculate nth Fibonacci number. Okay, so this will be n into n, this will be order of n square. Okay, I hope it is clear to you. So this will not be accepting, the code will not be accepted. So in that case we have one more solution, that is order of 1. So what you have to do is, you have a golden number, I hope you know that golden number, and that golden number is 1 minus under root of 5 whole divided by 2. Okay, this under root of 5 whole divided by 2, it is actually a golden number, and there is a golden mean. That golden mean is 1 plus under root of 5 divided by 2. So if this is those things, you have to just remember. If you are a math student, somewhere if you go through some high level math, then it is there. Okay, so this is the golden number and this is the golden mean. So what you have to do is, for calculating this answer, what you will do is, you will do this. Okay, for golden mean you will take this GM, for GM golden mean you will take root square power of this, and you will do minus of GN. Okay, gn to the power n. Okay, so you will do these two things, and if you subtract these two, then you will give your you will get your actual dynamic programming, sorry, actual nth Fibonacci number. So let's code it out. Okay, so okay, so I'm again implementing this thing. Okay, I think this video will length will be might be a bigger, so you can do it by your own. If you are not able to solve it, you can give me a comment or something like that. I'll again give you the code. Okay, actually it's actually a code. If you write the same thing, no, it will be working in like you have to add double here and double here, and for answer you have to also write double here. So yeah, actually a pseudo code. If you write same thing in CPP in with some integer values or double value of float values, taking golden mean as an integer or float, actually you have to take double because it will be some round of some pointed number. So it is actually code. Actually you can, if you are implementing this, you will be able to do that. Okay, so thank you so much